Hi, I'm Stephanie. I'm currently a second year student in the Occupational Therapist Assistant and Physiotherapist Assistant program here at Niagara College. And so today I'm just going to be doing a quick little video to help explain the concave convex rule. So I know when I was in first year, this was one of the most difficult concepts for me to wrap my head around. And not necessarily in the sense because it's hard, but because I wasn't using the proper tricks and I didn't have that visual image of what was actually happening within the joint. So that's what I'm going to be going through today. I'm going to be giving you two little tips and tricks that you can use. One's with just some basic paper and one's with your own two hands. So the two hands one's really easy because I remember when I was in first year doing the test, this saved me. Doing this motion that I'll explain later, but it really helped me to understand what was happening within the joints. So to start, a brief little description. What is the concave and convex rule? So all this is saying is it's showing you the relationship between articular surfaces and how they're moving on one another. So that could mean whether the concave side is moving on the convex side or if the convex side is moving on the concave side. So that's pretty much the basis of it. So now we're going to dive into the first trick, which is going to be the paper trick, and I'm just going to have two little pieces of paper to demonstrate the concave and the convex bone. So to start, I did label each of the bones, the femur for the convex bone and the tibia for the concave bone. So these are just the bones of the lower extremity, and I just thought that that would provide a better visual representation of what's actually going on. So to start, let's hold the concave bone stationary, which would be the tibia, and let's move the convex bone along the joint surface. So if I'm moving this joint surface in an upwards motion, you'll notice that the rest of the bone is going in a downwards motion. Same with if I move the joint surface in a downwards motion, the rest of the bone is going in an upwards motion. And then you'll notice that the opposite occurs with the concave on convex. So if we're taking the tibia and we're moving it downwards onto the convex surface, the rest of the bone also moves downwards as well. Whereas if we move it upwards, the same thing happens where you're getting the same reaction between the bone. So what this is saying is in a movement such as a squat, where your tibia is going to stay stationary and your femur is going to move on the concave surface, if we're going upwards, the rest of the bone is going to have the opposite reaction to what's going on at the joint surface. Same with going downwards, once again, opposite reaction. So that's represented in an exercise such as squat, whereas a concave on convex movement would be something more along the lines of a hamstring curl. So in an exercise such as a hamstring curl, your femur is going to stay stationary and your tibia is actually going to be moving along your femur, which would create a concave on convex reaction, resulting in the same movement going on at the joint as it is going on at the end of the bone. So although the papers are a really good tool to help get that better visual representation, we don't necessarily have time to create this type of tool within an environment like a test. So another way that you can learn and just kind of help remind yourself, especially if you're looking at a practical question, is to think of what bone is going to be your concave bone and what bone is going to be your convex bone. So the way that we're going to do this is we're going to put our hands over top of each other. And so if we want to talk about a concave surface moving on a convex surface, you're going to be doing this motion right here. Keep in mind, you don't want to be bending your wrist. You want to keep your hands straight and you want to only move your elbow to represent that bone movement. So as you can see, if I'm taking the concave surface and I'm moving it upwards, my elbow's also going upwards. Whereas if I take this concave surface down, my elbow's also coming down. Where once again, you'll see that the opposite occurs when it's a convex on a concave. So if I'm moving the joint surface downwards, my knuckles are pointing towards the ground now, my elbow is pointing upwards. Where the opposite occurs, if I'm moving down, or if I'm moving the joint surface upwards, my elbow is going downwards. So this is a really simple tool that you can use in a test in any sort of environment just to help remind you of what's actually going on at those joint surfaces and what's moving on what. So I hope this video helped to better explain the relationship between joint surface and the body segment movement. So in a nutshell, keep in mind, if it's a concave moving on convex, the joint surface is moving in the same direction as the rest of the body segment, whereas if it's convex on concave, you're going to get the opposite reaction. I want to wish you all the best of luck moving forward in this program. I understand some of the concepts can be hard to learn, however, they are very fundamental to what it takes to be a physiotherapist assistant and an occupational therapist assistant. So study hard, make sure that you're actually understanding the content and not just memorizing it, because it will really help you in the long run, as everything in this program is connected in one way or another. Best of luck, guys!